Hey everybody, this is Mr. Murray. Just take a couple minutes to get ready. This song requested by Miss Barris.
So get up, tell the bookie put a bet on not a damn thing will go wrong. The odds are that we will probably be alright. Odds are we gonna be alright. Odds are we gonna be alright tonight. The odds are that we will probably be alright. Odds are we gonna be alright. Odds are we gonna be alright for another night. Hit by the A train, crashed in an airplane. I wouldn't recommend either one. Killed by a great white or a meteorite. I guess there ain't a way to go that's fun. But somewhere in the world someone is gonna fall in love by the end of this song. So get up, no it's never gonna let up, so you might as well sing along. The odds are that we will probably be alright. Odds are we gonna be alright. Odds are we gonna be alright tonight. The odds are that we will probably be alright. Odds are we gonna be alright. Odds are we gonna be alright for another night. Sure things go wrong, but I'll take my chances. Odds are long, so why not play? Struck by lightning sounds pretty frightening, but you know the chances are so small. Hit by the A train, crashed in an airplane. Better chance you're gonna buy it at the mall. But it's a 23 or 4 to 1 that you can fall in love by the end of this song. So get up, no I'm never gonna let up, so you might as well sing along. The odds are that we will probably be alright. Odds are we gonna be.
Oh, that is so funny. Okay, so welcome to another video with Mr. Murray, and today we're going to be talking about parabolas. So just a quick review of what you already know about parabolas. I wrote them here in your notes. So certain things like, you know, if a is bigger than 0, they'll open upwards. So here's an example. We'll go back to regular mode. Okay. That would be a nice y equals x squared, where the coefficient is positive. If it's opening downward, well then obviously the coefficient of a is negative. So that would look something like this. Okay, so that would be negative. Standard form is ax squared plus bx plus c, and you know we use that a lot for quadratic formula. And this might be a little bit of a blast from the past, but from your Algebra 1 days, this is the equation of a parabola in vertex form, where h and k is the vertex, and you might remember the old negative b over 2a would be the axis of symmetry. Axis of symmetry being the line that goes right down the center of the parabola. Okay, so today in this class, Algebra 2, you're going to forget everything you knew about parabolas, and we're going to learn something completely different, like you've never known before. Okay, so here's the story. This boy, oops. Okay, here's the story. This boy named Algebra, he lived next door to a girl named Geometry. And he always wanted to hang out with this girl named Geometry. Look at this picture, it's fantastic. But his parents, well, had none of this, because they said that this Geometry girl was pure evil, and that she had these strange powers of locus. So she could like take a point, and then she could make a locus of all other points 5 away from this point, and this strange shape would emerge. Or she could take a line and another line, and she could make these beautiful locus of points right down the middle. So in Algebra's house, that was unheard of. However, he was still very curious what's going on with this girl. So she's going to move. They're both in high school. He sees the for sale sign go up, and he realizes that she's leaving town. And he says to himself, this is the last time I can ever speak to this girl before I ever see her again in my life. So late at night, he sneaks out, starts throwing rocks at her window. She comes running down, and there they are, and they meet. And he wants to tell her so much, and he's trying to show off, and he's saying, you know, hey, look at these things that I can make, and look what I do with all of my powers. And he draws this graph, and he's got this beautiful parabola, and she starts cracking up, laughing hysterically at him. So he's embarrassed, and he says, why are you laughing at me? So she draws this point, and she says, look, this is a focus. Then she draws a line underneath the focus and says, that's a directrix. Now, if I can make a locus of points equidistant from this point and this line, she said, watch what happens. So here's the middle. And what about over here? If I go this far, over this way, to meet the same distance this way, I'd be right about here. And then over here, if I went this far, I'd go around that far down, right there. And so on and so on. And here is this most beautiful parabola you've ever seen. So with that, the lights go on at the guy's house. Algebra's dad woke up. So he gives her one last look, and he realizes he'll never see her again. And he said, listen, I want to learn so much more about these locusts and these beautiful parabolas. So of course she said, listen, go to Zanfini's class. She's got all the information, and get out of here. I'm leaving town. Goodbye. The whole town turned on him. He had nowhere to go. Everyone thought he was turning to witchcraft, and that he was doing all of these hocus-pocus locusts. It wasn't very pretty.
Mostly retirees live here. They like it here.
Very park-like because there's a lot of trees.
They like the fact that they all kind of know each other. But in the last year, they say an oddball moved in who was nice but kept to himself.
The only time I've seen him is when he was at the mailbox, and if we were outside, and we'd wave and say hi.
He was soon forced out of his neighborhood, and signs were popping up all over the place. Okay, well, more on that later. So what we're going to learn today is that, indeed, a parabola can be created using this focus and directrix. And the focus is really just nothing more than a point, you know, anywhere on the plane. Here's this guy here in green. And a directrix would be a line. And if you can draw the locus of points that are equidistant from this point and that line, well, watch, you can kind of start right here in the middle. You know, pick the midpoint. So you have the focus, the thing called the directrix, and if I went to the midpoint, I'd put a dot right there. And you can do that all the way around, making this shape of a parabola. So look what happened here. We went out this much and went down the same distance. So we have a distance from the directrix moving up and a distance from the focus moving out. And when those two distances are the same, you plot a point. Moving further down the directrix, you move up, and from the focus you move out. And where those two lines connect at the same distance, you put another dot. If you connect these points, it's really cool. You end up with a parabola. So geometry was actually correct. And a parabola is really a collection of points formed from a locus of all points equidistant from this line called the directrix and this focus. And a couple of important things to remember. So let me just clear this ink real quick. Okay, this focus will always be inside the parabola. And the directrix will always be outside the parabola. The focus always lies on the axis of symmetry, so it can always be found right here along the center of the parabola. And the directrix has to be perpendicular to that axis of symmetry. And if you look at the diagram here, there's the 90-degree symbol showing you that it's perpendicular. Now the new equation that you're going to have to memorize is this guy right here. And this is what we'll be using for the next few days. So it's what they call vertex form, but it's a little modified from the original vertex form that you knew, which was here, right? So we added something. You'll see that we added a p. So the formula is x minus h squared equals 4 times p times y minus k. So here's the new stuff for today, this p. And here's the definition. So p is just the difference from the vertex to the focus, or you can take the difference, the distance from the focus to the directrix, and cut that in half. Okay, so check out this diagram, a little bit larger view. The p is this distance right here. And that's what you're going to use here in the formula. Okay, but you know, sometimes you'll be given a focus and a vertex, or a focus and a directrix, or maybe just the directrix and the vertex. You don't know what you're going to get. So it's important that you remember that this distance here from the focus to the vertex is actually the same distance from the vertex to the directrix. And if you remember what we spoke about, how you make the parabola, the locus, equidistant from the focus to the directrix, it would make sense that this point right here in the middle is the midpoint. So whatever this distance is, that distance will be. So here's a great question. Given focus 0, 4, directrix y equals -4, define the equation of the parabola in vertex form and sketch the result. Okay, so let's take a look at this. I'm going to graph what I can. So I have a focus and I have a directrix, so that's what I want to start with. That's my focus. Directrix y equals -4, so that is going to be this line right here. All points along this line will have a y coordinate of -4. So I'll write underneath it, directrix y equals -4. So what do I need? I need to fill in the equation that looks like this. X minus h all squared equals 4 times p times y minus k. Now, h and k are the vertex. So I need that. P is the distance. And it's that distance from the vertex to the focus. I'd like you to write this down as I'm writing. These would make great notes for you when you go back and study. Okay, so up here, I forgot to write this. We'll just say need, because this is what you need. Okay. So, vertex. Don't know where that is. It wasn't given to me. How about P, the distance from the vertex to the focus? No, I don't know what that is either because I don't have the vertex. Okay, so right away we have one of these tricky questions. Where is my focus? I'm sorry, where is my vertex? So the vertex is going to be equidistant from the focus to the directrix. So if you take this distance and cut it in half, find the midpoint, that will be the vertex. So it's pretty intuitive. It's not like we're doing anything crazy. So there's my vertex, and that vertex is located at the origin, or 0, 0. Okay, so now that I know my vertex, h and k is actually equal to 0, 0. So let me start to plug that in. X minus 0 squared equals 4 times p times y minus 0. That's my h, and that's my k. Okay, so we're just missing p. Now that we know the vertex, p is pretty simple to find. It's the distance from the vertex to the focus. So it's this guy right here. So how much is that? 1, 2, 3, 4. Okay, so p equals 4. Let's finish this. X minus 0 squared equals 4 times 4 times y minus 0. Simplifying, combining like terms, all that jazz, we have x minus 0 squared equals 16 y minus 0. And to be fancy for the dinner parties, you would say x squared equals 16y. Bam. Okay, so now we're looking for p. We still don't know what p is. So if we look at the graph that we just sketched, you can see that you have the vertex and we have the directrix. That's going to be the same distance as from the vertex to the focus, which we said was going to be inside the parabola. So let me just find out what this distance is. It's 1, 2, 3, 4, 5, 6. So P is 6. Piece of cake. Now let's draw that focus. 1, 2, 3, 4, 5, 6. It lives right here. That's our focus. And that point will be 2, 7. So now the equation of this parabola, which I'll sketch in a second, is going to be x minus my h, which is 2, all squared, equals 4 times my p, which is 6, times y minus my k, which was 1. Combining like terms and making this look nice, you have x minus 2 squared equals 24 times y minus 1. That's it, you're done. Now let's graph this and just make it look a little nicer. So here's the vertex at 2, 1. And I know that my focus has to be sitting inside of the parabola. And I want to find all points equidistant. So this is how I do it. If this is 6 this way and 6 this way, then if I went all the way out here, total of 12, right? 12 from this focus down to the directrix. So if I went 2, 4, 6, 8, 10, all the way out here, 12 to the left, I would have the same distance to the directrix, 12 down, right? 2, 4, 6, 8, 10, 12. So that's right. So I'd have a point all the way out here that's equidistant from the focus, 12 to the left, to the directrix, 12 down. So I kind of ran out of space here, you know what I'm saying? So if I tried to go 12 to the right, I'd be way off the page. So I'll just put a little dot there. But if I connected these points through the vertex, this is a very, very wide parabola doing something like this. And it's heading out that way. But if you notice, it certainly meets the rules of a locus. It's the collection of points equidistant from the locus, from the focus to the directrix. Okay, so these next two I'd like you to try on your own. I'll be writing them on the screen if you'd like to watch along. You could mute if you'd like, pause it, you know, whatever you're into. While I'm working these out, we'll be listening to some Paramore. Okay, so I hope you were able to work that out. I just wanted to show you a couple of gotchas. Right here, I highlighted in purple the negative of a -1. So the vertex had a k value of -1. So the formula says it's 4p times y minus your k value. All right, so if your k value is negative, you'll have a double negative. That will make it positive. And the other thing is this. If you remember from the first page of your notes, I said that parabolas can be negative, and when they are, they open downward. The way you'll see that here is when you find a difference from your directrix to your vertex, it will be a negative. So the absolute value of this distance is 5, that's for sure. However, it's -5 as we head in this direction downward. So why don't we try to finish this? I mean, now we have our equation, so that's fine. We're done there. But let's see if we can graph this. Where would the focus be? So we say that the focus is always within the parabola. And if this is the vertex, and I'm envisioning that my parabola is doing something like this, my focus must be in this area somewhere. Where will it be? Well, we know it will be exactly 5 units from the vertex because that's the distance that it is from the directrix. So however long you travel from here to here, you just do the same. 1, 2, 3, 4, 5, right here. That's my focus. And the focus is located at 2, -7. Notice it's on the same axes as the axis of symmetry. Along the axis of symmetry, you will always find your vertex and your focus. And notice again that the axis of symmetry is perpendicular to the directrix. So if I were to plot some points and take a wild guess, I would say 7 is the total distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 10 is the total difference. That's right, twice p. So if I move 10 this way, 2, 4, 6, 8, 10, I'd be somewhere over here. So I'm going to scoop in. Wow, that's again a very wide parabola. Very wide parabola. But notice, the directrix is here. The parabola always opens up away from the directrix, and the focus is always on the inside. If your P is ever negative, that will cause you to have a parabola that's opening downward. Okay, so for those of you who are wondering what happened to geometry and algebra during a special 2-hour finale, they proposed.
And I want to keep on loving you for the rest of my entire life. You said. Will you make me the happiest man on earth and marry me?
Yes. Yes. Oh my goodness.
Shaking.
Yeah.